The first part of this question sets us up for the second part. So I'm gonna start from the left-hand side and let it equal C. Let C, sometimes it's good to just introduce like a temporary thing that it's equal to. Let C equal log to base x of y. Now this implies that y will equal x to the c. That's how log works. The base to the power of this c is equal to y. And we want to show that c is also equal to log to base x to the power n of y to the n. What we can do is try and change the base to x to the n. So this means that y to the n will equal x to the cn, or x to the c to the n, maybe I should write. However, this is equal to x to the n to the c, just using the third rule of indices. You can swap these around, you're just timesing them together, so it doesn't matter what order you do it in. And that means that c will equal log to base x to the n of y to the n, because x to the n to the power of c is equal to y to the n, just like we had before. And so the result has been proven. I don't know why I'm putting a box around that, because that's not actually what I wanted to show. Therefore, log to base x of y equals log to base x to the n of y to the n. Now we have three equations to solve that you can see they involve bases that are going to be powers of 2 and so on. So we're going to be using this result that we've just proven, and we can just like go ahead and use it where we need to now. So let's look at the first one. Now I'm gonna stick with using 2 as my main base. So I can write log to base 4 as 2 squared, and then we've got u squared, plus log to base 2 cubed of u cubed, and then 2 to the 4 u to the 4. But we've just shown that each of these is going to equal, it's just going to be log to base 2 of u, because literally that's what we've just shown. We can just get rid of the n and have it by itself. So it's going to be log to base 2 of u plus log to base 2 of u plus log to base 2 of u plus log to base 2 of u is equal to 5. Or 4 log to base 2 of u is equal to 5. And therefore u is going to equal 2 to the power of 5 over 4. Really neat being able to solve like this. Look, this looks horrendous, but suddenly you can just use that result from above and it all just falls into place. Okay, let's take a look at the second one. Okay, this time we don't have u squared and so on, but we can still, we can still get around it. We can just think, how could we write this as, say, v squared? Well, it would be v to the half all squared. So that's how I'm going to go about it. So log to base 2 of v plus log to base 2 squared of v to the half squared plus log to base 2 cubed, and then I can make it v to the third cubed, plus log to base 2 to the 4, v to the quarter to the 4 is equal to 5. Now, using that rule from like that thing we proved in part A, I can just change it all to being, again, in terms of base 2. Okay, this time we can't just add the logs like we did, but we can use the first rule of logs and multiply them all. And then we can just add the powers. Look for a common denominator. It's going to have to be 12. So it's going to be, remember, we've got v to the 1 here. So 12 over 12 plus 6 over 12 plus 4 over 12 plus 3 over 12. Add these up, 18, 22, 25. So that means that v to the 25 over 12 is going to equal 2 to the 5. And what we can do is we can raise both sides. Actually, I'm going to actually write this line in. We can raise both sides to the power of 12 over 25. Because these are inverse operations, essentially they cancel. And then we times these, times by 5, and we can cancel that out. So we're going to be left with 2 to the 12 over 5. This just leaves us with the third question. So we've got log to base 2 of w, and therefore I think it's going to make sense to write this as 2 squared, w squared. And then actually log to base 8 of 64 is, well, we need to think about what we raise 8 to get 64. It's just going to be 2. So I can just replace that. And then I can use part A and write this as log to base 2 of w plus 6 over log to base 2 of w is equal to 5. I'm going to multiply through by log to base 2 of w. So this is going to be squared. It's going to disappear from here. And I'm going to get 5 log to base 2 of w. And essentially I've got a quadratic in log to base 2 of w. So if you wanted, you could do a substitution, call it y or something, y squared minus 5y plus 6 equals 0. Or if you're happy to, just factorize directly for log to base 2 of w. Going to need this here, and then it's going to be minus 2 and minus 3. So in fact, there's going to be 3 answers here. W is either going to be 2 squared or 2 to the 3. Great question. Hope you enjoyed it as much as I did. Well done.